Hello students. We've just finished looking at basic linear inequalities. Today we're going to expand on that notion and we're going to look at something called compound linear inequalities. So we're going to start by solving compound linear inequalities. To begin with, let's take a look at the board, and I have two statements on the board. Find all values of x such that the following is true. Number one, x plus 1 is less than or equal to 9, and x minus 2 is greater than or equal to 3. That's the first statement. So I'd want all the values of x that work here and work here. And then the second, a different problem, would be find all the values of x such that 2x is greater than 4, or 3x minus 7 is less than 5. So here I'm looking for values of x that work here or work here. What are we looking at in these problems here? We're looking at inequalities that are joined by a conjunction, either and or. These make compound inequalities. Anytime you have two inequalities joined by and or, it makes a compound inequality. So how do we go about solving them? Well, in math, and or have entirely different meanings. So we're going to look at the and part first, and then we'll look at or after that. So let's start by taking a look at the word and. What does and really mean in math? And means intersection in mathematics. An intersection has a symbol, and that symbol is an upside down U. So let me just say right here that and means intersection, and that is classified or symbolized by an upside down U. So this means intersection. And I have a quick little definition up on font that explains what intersection is. It says as follows. In math, the word and corresponds to intersection, and for a number to be in the intersection of two sets, it must be in both sets. Think about it. If you are at two streets and you're at the intersection of two streets, you are where the two streets meet. Intersection, think where two sets meet or two sets overlap. So, intersection means where two things meet or overlap. So, let's take a look at some examples then of compound inequalities involving and. Let's look here. Since and might still be kind of new to you, we're going to first look at Venn diagrams, and then we'll actually look at inequalities. So let's take an example. Suppose I have a set C right here, and then I have another set. Let's make it a blue set. This is the set D. And so D consists of everything that's in D. C consists of everything that's in C. And my question is, I want to know, what is C intersect D? Where would be the place where both sets meet or overlap? Well, C and D overlap right here. Do you see that? It's where they overlap and where they meet. That would be the intersection of these two sets, where they overlap. Let's take a different type of an example. Let's actually take some numbers. Let's take the numbers 0, 1, 2, 3, 4, 5 as our first set. Let's call this set C. And let's take a second set called D. Let's make this a set of numbers, maybe 0, 2, 4, 6, 8. And again, we'll ask the question, what is C intersect D? What are all the elements that lie in C and lie in D? Well, it's everything that overlaps, everything that meets. And so this would be 0, 2, and 4. Those are the only elements that lie in both sets C and D, and that's the intersection of the two sets. So now, how does this apply intersection? How does this apply to our inequalities? Well, let's take two intervals and let's see the intersection of these intervals. Let's let C be the interval negative infinity to 2, and let's let D be the interval negative 3 to infinity. And let's again ask the question, what is C intersect D? Well, to help us here, it might help us to visualize these on the number line, and that's what I'm going to do first. I'm going to first of all say, okay, let's look at these on the number line here. Let's draw a number line, and let's get -4, -3, -2, -1, 0, 1, 2, 3, okay? And let's draw our two sets, C and D. C would be everything from -infinity to 2. So that would be this set right here. This is C. Do you guys see that? It's everything from -infinity to 2. Now, I'm not drawing it on the number line. I'm just drawing it above it because I'm going to compare. Now, D is -3 to infinity. All the numbers that are bigger than -3 towards infinity. So D actually represents this set right here. And what I'm looking for is C intersect D. C intersect D. And what is C intersect D? It's where C and D overlap. Where do they overlap? Well, let's see. Where do they overlap? So they start to overlap right here, you see, then they're overlapping, 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 and then they finish overlapping right there. So they overlap in between -3 and 2. And so my solution then, C intersect D, is actually this set right here of numbers between -3 and 2. Does that make sense? That's where the overlap or the intersection is. So I'm intersecting from -3 to 2, and that would be the intersection then for these two sets. And then let's take a look at one more. Now we're all set to do our linear inequality. So now let's look at a compound linear inequality. Let's take x plus 1 is less than or equal to 6, and negative 2x is less than -14. And how do we do this? Let's see. What's our first step? Our first step when you have an and is to think intersection. So we're going to intersect two sets. Now what's the two sets we're intersecting? One here and one here, like C and D. So your first step is to first of all figure out what your two sets are. So solving this from last time, just like equations, except when you have negatives, change your sign when you're multiplying, but we get x less than or equal to 5, and over here we're going to divide by -2, and remember this is a negative number that we're dividing by, so you're reversing the direction of the sign. We get x is greater than 7. So we've got x less than or equal to 5 and x greater than 7. So let's put this on the number line and let's see what the intersection is. As we go about it, we've got 0, 1, 2, 3, 4, 5, 6, 7, 8. I want all numbers that satisfy this and intersecting this. So first start by sketching x less than or equal to 5. Here's 5. I want everything less than or equal to 5. That's x less than or equal to 5 right there. And now I want x greater than 7 right here. Uh-oh. And I am looking for the overlap. Where do they overlap? They don't overlap, do they? This one goes this way, this one goes this way. They never overlap. So there are no numbers that work here and here at the same time. It's impossible. You can't be less than 5 and greater than 7 at the same time. So what do we put? Well, there are no numbers that are going to work. So our answer is going to look like this. It's going to be the null set. Now this is rare that you get this, but every now and then you do. You get a compound inequality that doesn't work. You have this not agreeing with this because there are no numbers that work in both of those. Okay, does that kind of give you an idea for and? We'll come back to and in a minute, but first of all, let's take a look at or. Okay? Or. In math, or means something called union. Or means something called union. So let me write down the word union and let me write down the word or. Or means union, and the symbol for union is a U. And I have a little definition that we'll pull up to describe what or means, and that's on font for us. And or says the following. It says the word or corresponds to union, like I said. Now, for a number to be in the union of two sets, it must be in at least one of the sets. Let me repeat. For a number to be in the union of two sets, it must be in at least one of the sets. What does this mean? Well, when I say union, when I think of a union of people, I think of a collection of everybody, okay? When you think of union, think of everything possible. So let's go back to our examples that we just put on the board to describe and let's take a look at how they would correspond to or. So let me erase this little red part in here. So again, C will be everything in here, and D then will be everything in the set D. And the question is, I want to know this time, not what is the intersection of the two sets, but I want to know what's the union of the two sets. In order for something to be in the union, it has to be in at least one of these. So everything here is in C. So that'll work. Everything in C works. And everything in D also works. The union just consists of everybody in both of the sets. Has to be in at least one of them, so it's everything in both the sets. The union is the whole picture in this case, if we're looking at a Venn diagram. Let's look over here at a set of two numbers then. We had the numbers 0, 1, 2, 3, 4, 5, and then the numbers 0, 2, 4, 6, 8, and we want the union. That means has to be in at least one of the sets, could be in both, but it's just everybody. Think union, think everybody. So let's see. We could start listing 0, 1, 2, 3, 4, 5. That's everybody in the first set. Now, is there anybody that we left off in the second set? We left off, we have 0, we have 2, we have 4. Who did we leave off? We left off 6, and we also have to include 8. So the union is just everybody from the collection of both of the sets. And let's take a look at this guy here. I'm going to erase my whole number line, and I'm going to redraw it again. I'm looking for the union of two intervals this time. And again, I'll put the two intervals on top so we can take a picture of it and look at it before we actually sketch the real thing. So we have -4, -3, -2, -1, 0, 1, 2, 3. And we were looking at the two sets. C is negative infinity to 2. This was set C. And D was -3 to infinity. This is set D. And I want the union. I want everything that lies in C. So all of this gets included. All of C together with all of D. And so what's happening? If we look at this, we're not looking at the intersection, we're now looking at the union. If I want the union, I want everything in C combined with everything in D, and that actually gives me the entire number line. So the union this time is everything from negative infinity to positive infinity. It's the whole number line. And let's take a look at the last example then. Again, what I'll do is I'll erase all this work here so we can get down to it again and take a look at it. But suppose I had the same two inequalities to start with. I had x plus 1 is less than or equal to 6, or negative 2x is less than negative 14. The key word here is or this time. And so how does that change our problem? Instead of looking for the values that work here and also here, I am just looking for any value that works here or works here. I'm looking for the union. So let's write this on the number line and let's see what kind of picture we get here. We get a picture then. So again, we'll start here and let's make this like 4, 5, 6, 7, 8, 9, 10. We want to graph everything less than or equal to 5. That's x less than or equal to 5. and then everything greater than 7, and again, I'm drawing it on top of the number line, and then we'll put our final result on the number line itself. But this is just to use to compare so we can see what's going on. Now, I want everything that lies in this set or this set, which means everything in this set together with everything in that set. So that's everything here from negative infinity to 5, right? That's for the first set. Or, meaning union together, combine that with everything in your other set, which in this case is 7 to infinity. And so what do we get? We get two disjoint intervals. Let me write that word down. Disjoint intervals. Disjoint meaning they're not connected, but they are both in our solution set, both of them. So how do we write this in interval notation? Well, we've got two intervals to deal with. Our first interval is negative infinity to 5. And our second interval is 7 to infinity. And we want to union these together. Now, first of all, let's just comment, right? We've got a closed bracket here because it was a less than or equal to. We've got an open bracket here because it was a greater than, and we always put opens that are infinities, right? So that might be why you got some notation here. But we want to union these together, right? We're unioning because the or means union. Union symbol is a U. So this is the interval notation to describe that picture right there. It's negative infinity to 5, union 7 to infinity. Okay. So I think we have the idea for what and or are and how they work. And is intersection, or is union. So what I have now is some exercises that kind of combine and or as practice. Let's erase this first. And then we'll look at some exercises where you actually have to figure out which one you want to do here. So let me erase this and put some examples up to work on. Here's our first example then. Our first example, or practice exercises, would be as follows. So exercises. Number 1. So let A equal the set negative infinity to negative 1. Let A be the set negative infinity to negative 1. And let's let B be the set negative 2 to 4. Now this exercise is going to practice working with our interval notation, putting it on the graph, and finding intersections and unions. So we'll let A be this and B be this. Now we're going to find two things. We're going to find A intersect B, and then we're going to find A union B. So I'll let that there. I'll let you start to work at that while I erase these over here. But again, we've got negative infinity to negative 1 as our first set, and then negative 2 to 4 as our second set. And we're going to find A intersect B and A union B. The first thing you probably want to do is put each of these intervals on the number line itself or above the number line so we can at least look at it and compare. So here we go. We got to get our number line lined up, so let's get negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, etc., etc., etc. And let's draw the set A, which is all the numbers from negative infinity to negative 1. Which is everything like from here to here. So this is our set A. And then our other set is negative 2 to 4. So this is set B. Now, we need two things. We need number 1, the intersection, and then number 2, the union. Let's start with the intersection first. Where do these things intersect? Well, they start to intersect or overlap right here, and they end overlapping right there. The intersection is everything from negative 2 to negative 1. That's it. That's the only place these two sets overlap. Those are the only numbers that fall both here and here. So our intersection then consists of all the numbers from -2 to -1. Not too bad. And we now look at the union. So I'll do the union in a different color, but I'll erase that blue just so we don't get confused here. So I'll erase the blue part, and I'll fix that up. And you're looking at the union this time. So you've got set A, and you've got set B. And you want to know this time, not where they overlap, but what are the elements that are in everything. So you need everything that lies in A, which is going to be all this, which is on your number line, all of this, that's all of A, combined with all of B. Well, B starts here and just keeps going all the way to here. Here it stops. So it's everything from here all the way here. Can you see that? That's the union of everybody. And so, what is that? In interval notation, what is that? That's the set from -infinity, union, okay, so it goes all the way to 4. So that would be the union of these two sets, everything from -infinity to 4. Okay, are we getting the idea a little bit more with intersection and union? Let's actually go about solving a linear inequality then. Let me erase this other example. We're going to solve a compound linear inequality. The first step will be to solve each separate inequality and then look at and or. Here we go. Let's take 7x plus 6 is less than or equal to 48, and -4x is greater than or equal to -28. 7x plus 6 is less than or equal to 48, and -4x is greater than or equal to -28. First step is solve each inequality separately. So how would we solve the first one? We'd start by subtracting 6, right? So we'd get 7x is less than or equal to 42. And then we would divide each side by 7, right? And so we would get x, because the 7's cancel, we would get x is less than or equal to 6. And keep that word because you have to know if you're intersecting or unioning. On the second inequality, we have to divide by -4. Let me star, right? Because when you divide by a negative, you reverse the direction of the symbol. So you get x, reversing the symbol, is less than or equal to 7. So I'll just put that here. So we have two statements. We're all set. X is less than or equal to 6, and x is less than or equal to 7. Some people could do this right in their head. We want the intersection of these two sets. I like to visualize it. So we're going to draw both the sets above the number line, compare them, and actually put the result on the number line itself. 8, 7, 6, 5, 4. That's good enough. We want all the things less than or equal to 6 for the first part. And for the second part, we want all the things less than or equal to 7. What are we doing? We're looking for and, which is intersection. Intersection means overlap. So where do they overlap? Well, they start to overlap here, right? Down here at -infinity, and it overlaps all the way till here. Doesn't it? Overlaps all the way till there, which is this set right here, which in interval notation says I want all the numbers from -infinity to 6, like this, right here. Does that make sense? And let's throw up one more inequality to solve. I think you guys have this down pat, but practice always helps, so let's do one more. That was example 2. This will be example 3, and this is what we'll finish with for the day. Let me get a better rag here to erase the board. So what we're going to do now is example 3. It's going to be an or statement this time, so we're going to union. Oh, this is a tricky one. Let's take 3x is less than or equal to x plus 12. or x plus 1 is greater than or equal to 10. Now I'm going to leave you solve and put these steps in here. You're going to work your way down. You're going to put the things on the number line. You're going to look at the union, and you should come up with negative infinity to 6, union 9 to infinity as your answer when you're done. This is an or, so you're going to union, but I'll leave those steps in there for you to fill out since we're almost out of time, but this way you can practice as well. That's compound linear inequalities. The key to remember is that and means intersection, or means union. Talk to you next time and we'll do something new.